First, we'll use the Gemini Nano Banana model. Generate some concept art to create a 3D zombie. For a stylized game, use a standard front-facing T-pose. Then, generate a left side view and a back view. Next, import these images into Hunyuan 3D. Click Generate. First, it generates the base model. Then, it retopologizes the model, converting triangles to quads. Finally, it generates the textures. Once generated, save it out as an OBJ file. Next, import the model into Mixamo. Then, use Mixamo's auto rigger to set up the skeleton. Once rigged, you can start applying animations. Pick 2 animations for each category. Things like locomotion, idle, attack, death, and falling animations. After selecting them, download and save the animations to your project folder. With everything ready, fire up your Unreal Engine project. All right, with the assets baked, let's import them into Unreal. Create a new folder and name it Assets. Now open the zombie folder we just created. First, import the character model. Then add the animations that come with it. Now scale the model up by 100 times. I'm doing this because I've imported it before and know this scale works. At this scale, when placed in the level, it will be life-sized. The animations have come in with it as well. Everything looks good so far. Next, import the remaining animations. Select all these files. The model's already in, so we just need to bring in the animations. In the Animation tab, just import the animations. All right, animations are all imported. Let's go through them one at a time. See if anything's off. If everything looks good, hit save. Next up, let's bring in the textures too. Save that, and next we'll generate the LODs. The default poly count here is a bit on the heavy side. We're looking at around 12,000 polys. That's putting a bit too much strain on the GPU. All right, let's cut it in half to 0.5. Then we'll generate 3 LOD levels. Each level will be a quarter, 0.25 of the previous one. Now click Apply Changes. Now we can see LOD 0, which is our highest detail level, has over 6,000 polygons. The next LOD is over 1,000 polygons, then down to 800. This looks decent. Actually, we could optimize it even more. But for now, let's stop here. Next, we'll bake our model into a mass battle agent. Now just click this button. This will open up the Mass Battle Tools palette. Drop your model in here and you'll see the 3 LOD levels appear. They're already detected and ready to go. The tool defaults to using 2 levels of animation blending. We'll leave this setting as is for the moment, so we'll just stick with the default values. Let's rename it and clean up any suffixes or extra characters. This is important because when we generate the assets, they'll be placed in a folder named after this. These animations are because of the animations we imported, all related to the keyword run falling. So it has been imported accordingly to each corresponding entry. If not, you'll need to fill it out yourself. Another one is the original textures. If you fill in these in this tool, it doesn't necessarily have to be filled in, but if you fill it in here, it will automatically be generated during the creation process. Generate with textures. This saves you the hassle of filling it in later, much more convenient. Once you've filled in normal, roughness, and all the other maps, click Batch Rename. This step is optional. You can click it or skip it. If you clicked it, all these assets will be renamed using the plugin standardized naming convention. They'll be renamed automatically. The advantage is, remember we had to manually assign those textures earlier? They didn't auto-detect because the file names lacked the correct keywords. Now, with keywords in the names, they will auto-detect. All right, let's say we need to rebake the animations, or add a couple of new animations. Then you'll notice these textures are automatically picked up by the system. This saves you from having to manually reassign them every time. We still need to clean up these file suffixes though. Once that's all set, hit that green generate button. It'll process everything and output the results into the Gen Zombie folder. Once it's done, save your work. Let's open it up and take a look. This is the agent's data asset. Now, this data asset contains all the properties for the agent that you can tweak right inside the editor. Common ones include health, size, the model's relative transform, and its orientation. For instance, when you first import it, the model might be facing sideways. So you might need to rotate it 90 degrees or adjust its scale. Things like movement speed, obstacle avoidance, and so on are all configurable here. We won't go into every single detail right now. For any property, if you hover your mouse over it, tooltips appear in both Chinese and English. This gives you a rough idea of what the property does. Next, let's inspect the VAT model we just baked. It looks okay, but we need to verify its animation. Now open the LOD0 material. If it's the default, it might look like this. So select the model and click this button. This will replace it with the correct model. In the layer parameters, open the debug section. Here you can enter different index values. Next, verify that all animations have been properly baked. Then drag this timeline slider. See if the animation blending works as expected. Once everything looks good, you can disable the debug mode. Next, head to the Details panel and look at the Material FX debug. For instance, the burn texture might be oversized. Open the burn settings and scale it down. The dissolve effect looks fine. Next, check the frozen effect. Finally, inspect the hit highlight and the poison color. If everything's good, save and close. All right, now we need to set up a scene. Then we'll spawn our troops into that scene. To do that, we can use Unreal Engine's built-in content pack. We'll add a top-down one. Once that's in, open the map and hit play. You'll see it looks like this. Good, we already have a playable character. Next up, we need to spawn enemies around our player. First, we need to edit the map. Specifically, the map needs a navigation system. This lets the zombies find a path to the character. Add a nav mesh bounds volume. Scale it up to cover the whole map. The green areas show where they can move. Press P to toggle its visibility. Next, add a flow field. The flow field is in Plugins, Mass Battle Content Core, Flow Field Canvas, BP. Drag the flow field actor from there into your level. Set its mode to use navmesh. All right, let's start by setting a target point for the flow field. Right now, this is set for preview. Click the player start. The flow field is now generated. These arrows can be resized. Following these flow field arrows will guide you to the center point of our map. Now here's the thing. Currently, the flow field's target point is static, but we need the target point to follow our character. Essentially, we need to set the character as the target point. But we can't set this here because our character spawns in during gameplay, so we'll need to set this up in the blueprint. Let's open up the character's blueprint. Then inside its begin play event node, let's add a get actor of class node and use it to find the BP flow field actor in the level. Then call set goal actors and plug in a reference to self. This sets the player character itself as a goal actor. Goal actors is a parameter in the flow field system. So this self reference and the goal actors parameter are one and the same. One is the default value set in the editor. The other is set at runtime. Once both are set up, now enable the runtime flow field preview. The arrows now follow the player. But the update rate is too slow. So open the performance settings and set it to update every 0.1 seconds. That update rate is plenty fast. With the flow field set up, disable the preview. Now you're ready to spawn enemies. Let's write the monster spawning logic in the level blueprint. Alternatively, you could create an actor to function as a spawner. The plugin's main offering is this spawning function. You can call it from anywhere. Now, inside the level blueprint's begin play event, we'll first execute the make template data from data asset node. Locate the data asset we just created and fill it in. The data asset will then be converted into a struct. This struct can also be used to spawn monsters. The benefit is that we can pre-configure the struct. Once the editing is done, we use the edited struct to spawn agents. This way, we avoid having to modify the agent's properties after it spawns. This is more efficient because the setup happens only once at runtime. Let's name this zombie template. So what do we need to configure for it? First, we need to assign it a flow field. We already have a flow field placed in the level. Now we just need to make our agent use it. So let's search for the set mass fragment node. Navigation. Then enable flow field to use. You might wonder how I knew this was navigation and how I knew to enable flow field to use, because within this data asset, all fragment names are listed here. Since this flow field resides in the navigation, including flow field to use, it's the same one. However, if you enter it here, it will work in the editor, but once packaged, it fails in the game. So I highly recommend that you avoid directly populating the data assets. Instead, set it up dynamically using blueprint nodes at runtime. Here, we'll also use the get actor of class node and search for the BP flow field actor. Then assign it. Once that's set up, we also need to configure the zombie AI. It needs to target the player character. We need to ensure it can find the player. What we need to set up here is the trace property. This property offers two different modes. The first mode simply treats player 0 as the target. The other mode uses a spatial query to locate targets. Given that we're building a top-down survivor-style game, the player character is obviously the primary target, so the first mode is more performance efficient. We can adjust it right here in the details panel. Alternatively, we can control it using blueprint nodes. For example, you could search for trace in the blueprint editor. Now change this mode. Using player 0 here has the same effect. Open this drop-down menu. If you don't know what fragments are available, click on Mass Fragment. At the top, locate a Mass Battle-based fragment and open it. These are the fragments specific to this plugin. They're all in this drop-down menu. Once these two are set up, we can begin spawning units. In the tick event, set it to spawn units every 0.2 seconds. Next, call the function to spawn enemies. Here we have the by config version and the by template version. Since we're using template to spawn enemies, so we'll use the template here. Set the shape to circular. This means enemies will spawn in a ring around the center point. Spawn one at a time. Use the zombie template as the source. Set their team to team 1. Here in the shape data section, you can change this to a ring shape. Then we have an inner radius and an outer radius. The nearest value is 750 and the farthest is 1000. The more segments you add, the rounder the circle becomes. If you set it to 3, it becomes a triangle. It's a triangle. Setting it to 4 turns it into a square. Here, let's add a random offset. Otherwise, they'll always spawn at the same few spots. Here, you can also add world static and world dynamic. This will detect the ground height and spawn the generated agent on the ground, instead of spawning them in midair. Once we've tweaked all these settings, we're good to go. Let's spawn some enemies and see how it works. The enemies have spawned successfully. It seems like the enemies are avoiding each other, but right now they're moving sideways. So we need to rotate the model. Since we're dealing with the model, we'll find its transform under the render component. Next, the value here is set to 90. The movement speed is a bit too fast, so in the move XY node, we can change this to 500. Then for its idle to move blend space, we can also change the range to 0 and 500. At 500, it plays the full movement animation. At 0, it plays the full idle animation. This way, the overall effect looks much more natural. Next up, we want it to be able to attack our player. We want our player and this monster to collide with each other. We need to add a Mass Battle Agent component to the player character. Add a Mass Battle Agent component. Once added, we also need to assign a data asset here. Let's just duplicate one and rename it. The idea is to spawn an invisible agent for the player that follows them around. This agent is the one responsible for taking the hits. Set the synchronization mode here to component to entity. This essentially means our character is piggybacking this agent around. If you use this mode, our character follows the agent's movement. The hierarchy is set up differently here. Once all changes are made, we also need to tweak the data asset, because this unit's sole purpose is to take hits. Therefore, we can disable many of its features. First, we don't need rendering. We don't need chasing. We don't need targeting or movement. No obstacle avoidance, no collisions, and no attacks. We don't need other death mechanics either. All of these behaviors are disabled for it. It just needs to take hits. Now we can enable Draw Collider Shape in the debug section. This lets us visualize its collision volume. First, it's following our character. And it can take hits, which is working. It's positioned a bit too high. That's because its pivot is the same as the mesh's. It's at the feet. Just like the mesh, place it at the feet. The anchor point is at the feet, matching the mesh. Run it again, and it should work fine. The health is a bit low. It dies in one hit. You can adjust the health value here. Tweak the base health directly, or adjust the health multiplier. For example, set the health multiplier to 100. That gives you 10,000 HP. It won't go down in just 2 hits. This monster's spawn rate also has a multiplier. You don't necessarily have to use this multiplier. It's there to help you quickly tweak the balance. Okay, once all these are set, now let's polish the zombie's attack behavior. First, its attack rate feels a bit too fast. Change it to attack every 2 seconds. Next, its attack range is too far, set it to 50. Wait, that's too close. Let's change it to... Actually, let's keep the attack range at 200. Each attack applies a 0.5 second cooldown. Within that 0.5 second window, it can still keep chasing enemies. This allows for hit and run. Let's change this value to 10. Let's see how it works. At a distance of 200, you hit once, move forward a couple of steps, then hit again. This way, you can have hordes of zombies attacking from varying ranges. This feels more intense. Also, when the player moves, they'll collide with these objects. Once dead, the collision is gone. Collision will be active. Alright, next up, let's make the player deal damage to zombies. we'll use the most straightforward approach. We'll do it right inside the player's tick event. Let's say every second or so, we'll add a 1-second delay, then trigger a spherical area of effect damage. Here, we'll just call apply radial damage and debuff directly. Setting keep count to 1 means it will damage every target within the radius. For the location, we'll use our own position. Just call get actor location. The hit from location will also be our own position. We need to specify a damage debuff here. Set the damage to 100, the radius to 500, and we'll need to configure the query parameters. Our players are assigned to Team 0. Our monsters belong to Team 1. So, to avoid friendly fire, we need to exclude the player's own team. In the exclude section, search for and add the Team 0 tag. Also, exclude the dying tag to ignore units that are already dying. Next, for debuffs, add a knockback effect. Add a segmented damage over time effect. Then add a slow effect. For this damage type, assign a poison effect. The instigator and causer fields can be left empty. If you fill this in, for example, get a mass battle agent, get its entity handle and pass it in. This is mainly for scoring purposes. For example, in the data asset, under statistics, there's a self-score, right? So eliminating this unit gives you 1 point. The question is, how does the system know who gets the point? You need to provide the attacker's entity handle during the attack event. Then, if it eliminates another unit, it can claim their points. Once everything is set up, let's run it and see how it works. The zombie's health is too low, it died in 1 hit. Change it to multiplying it by 10. So it has 1,000 hit points. You can see it has burn damage, then it slows down with a slowing effect and also has knockback. For example, I want to make the jump text smaller and also reduce the size of the health bar. Then you can directly modify the popping text size in the data assets. I exposed it. Changing 300 to 200 will make it smaller. As for the health bar, I haven't exposed this dimension. So you have to find the renderer responsible for rendering this Niagara system. Then here is the emitter responsible for rendering its health bar. Now adjust the size to 75. Alright, there's still one more issue we need to address. See, the zombie can actually get knocked back into the wall. The problem is, the environment isn't currently set up to collide with it. It only interacts with the ground right now. Here's what I recommend. If you're new to this plugin and want a quick solution, you should enable the Move XY Docene Trace option on the zombie. Once you check that box, it will start checking against the collision channel you've specified. It will then automatically collide with obstacles in the scene. See, collisions are working. Now, if the footstep placement looks like it's floating a bit above the ground, that's because the flow field we've generated doesn't perfectly conform to the terrain. However, we're sampling the ground height from the nav mesh. So it might not be a perfect fit. First, you can adjust the precision of the nav mesh height. For example, change step height to 5. Then at this point, you set the draw offset to 0. You can see it's already very close to the ground. In that case, this sense of floating will be greatly diminished. However, after all, it is still obtaining altitude from a simplified version of the ground. Sometimes it's still not accurate enough. Some of these places have sunk below the ground. Your zombie's foot might get stuck in the ground. For pinpoint accuracy, in Move Z, set the ground detection mode to raycast. This performs a raycast against the ground. It's perfectly accurate, preventing characters from sinking through the ground. But there's a performance cost. In my tests, performance remains solid. If you enable raycast for both, for scene obstacles, and for ground detection, you can still handle around 10,000 units at 60 FPS. But if you're aiming for better performance, you'll need to use some faster obstacles. For instance, here I'll still go with the flow field. I've also disabled the scene collision, but what if I still want collision with the scene? I've included a few fast colliders specifically for performance optimization. In the core neighbor grid here, you'll find a box. Let's, for example, put it here. Then there's a capsule. You can also adjust the capsule collider radius here. And here's the spline collider as well. We'll block the path right here using this spline. This will stop enemies from getting through. Not sure about the orientation, it might be flipped. See, it's blocked now by the spline. Where there's no spline blocking, you can still push through. Alright, next let's add some hit feedback to our character. For example, we'll add a health bar, and we'll also add a ragdoll effect for when they die. Open the character. Then we need to add the Mass Battle Agent interface to it. Once we've added this interface, we can see a number of events become available. The ones we need here are the on-hit and on-death events. The on-hit event fires when the agent takes damage, and the on-death event triggers upon death. This refers to the red ghost entity bound to our player, this proxy unit. Next up, there's one more thing we need to do. Open the player's data asset. Ensure the event we need is enabled. It's off by default. If it's off, you won't get this event. But if you enable it, it does come with a performance cost. That's why it's disabled by default. Let's do a print to see if it's working. For now, let's stop it from attacking. Check the top left corner, hit, death. Great, the event is firing correctly. Alright, next up we need to work with these two components. They'll handle updating the health bar and activating the ragdoll. Let's start with the health bar. Good news, the plugin includes a pre-made health bar asset. You'll find it in the content folder under Demo Player. Open the third-person character blueprint that comes with the plugin. You'll see it has a health bar widget. I'm going to copy that over. Then, in the Begin Play event, we'll store a reference to this widget. We'll use a Get Widget node to access it and check which specific widget it's using. You'll see it's named WB Player Health Bar. Alright, cast this to the WB Player Health Bar widget. Let's store that reference for later. Next, we can go ahead and call its update function. For the size, we can just set it to show 0 and 1 for now. Now we need to populate the health value. To do that, we need to fetch the player's bound agent. For the health, we'll use the Get Entity Handle node. Then, we'll follow that with a Get Mass Fragment node. To retrieve the health, we'll pull it from the health fragment. We'll grab both the current and maximum health values and plug them in. Let's run it and see. Now the health bar shows our player's current HP, but it's not updating in real time yet. Next, we'll update the health bar in the onHit function. every time the player takes damage, we'll refresh the health bar. We'll get the current HP and then reassign its value. Since we already saved a reference to it, right here. Plug it in here. Let's see if it updates properly now. Perfect, it's working. Next, let's set up the death sequence. For the death state, we want the character model to go into Ragdoll Physics Simulation. First, open the collision properties and ensure the mesh has collision enabled. This allows it to collide properly with the ground. Now we can enable simulate physics. Next, we need to stop all active movement. Finally, we need to disable player control of the character. To do this, we need to get the controller reference. The UE third-person player here is not what you'd expect. It doesn't use a player controller. Instead, it uses an AI controller. So here, you need to use getController. Don't use getPlayer0, that won't work. So now, disable input. Then after 2 seconds, we can remove it. And since we've already placed in the scene, a player start will respawn randomly at one of the player starts. You don't need to code this logic yourself, because it's a built-in feature of Unreal Engine. Just drop it in and you're good to go. It's best to place it on the ground. One, two, and respawn. Now, let's look at how to create a 2-army battle game mode. First, open a blank map. Go to Window, then Environment Light Mixer. Click on all the buttons. Next up, we need to create a terrain. Here, click on Landscape to create it. Then, under the Sculpt tab, we'll use this noise tool. Paint in some random terrain variations and elevations. Once that's all set up, we need to add a flow field to our scene. Go to Plugins, find Mass Battle, then Content, Core, and open the Flow Field Canvas blueprint. Drag and drop the flow field into the scene and center it. As you can see, the flow field doesn't cover our entire terrain, so we need to lower its position and then increase its height. Ensure the flow field's bounding box fully encloses our terrain. Ultimately, these flow field arrows or sampling points shouldn't be making contact with the ground. So, we need to find the environment query context and enable the Detect Ground checkbox. Then, assign the ground's object channel. Once everything is configured, scale up the flow field size a bit. Save. As this is a battle between 2 factions, each side will have a main base. Success is achieved by destroying the opponent's main base. First, let's place 2 spheres to act as proxies for the enemy's main base. For example, let's designate the left side as Team 0 and the right side as Team 1. Each side has its own home base. We also need to duplicate our flow field. Let's name the first flow field Team 0. Name the second one Team 1. Team 0 will then use its flow field to navigate to Team 1's home base. Likewise, Team 1 will use its own flow field to head for Team 0's home base. So for Team 0's flow field, let's set Team 1's home base as the destination first. Similarly, for Team 1's flow field, add Team 0's home base as its target. Now let's see how it works. Take Team 0's flow field, for instance. It keeps moving rightward and ultimately heads straight for the enemy's main base. You might notice some unnatural looking spots here. That's because the path makes a sharp turn here, resulting in this kind of line. It might look a bit off. If you want your troops to turn in a smooth, orderly arc, you'll need to manually tweak the flow field. Open the Modifiers panel and add a Direction Modifier spline here. Next, we'll draw the spline curve. Extend the spline all the way to this point, making it end right at the enemy's main base. Alright, got it. Let's tidy up these spline handles to make them more uniform. There we go, one spline is created. We'll place this modifier under Team 0. Next, click the Draw Debug button. You'll see a blue debug line has been generated. The arrows on this blue line are oriented precisely based on the path and orientation of our spline. So, as you'd expect, if our agents follow these blue arrows, they'll navigate the turn in a very crisp and orderly formation, and won't look unnatural. We can crank up the width of the spline. Likewise, we can add another spline on the opposite side. Now, check out these spots behind the sphere. They don't actually connect to the sphere, so we can tweak it a bit to fix that. Let's drag and drop a Direction Modifier Sphere modifier. Snap it into place roughly around here on the sphere. Next, bump up its priority. And then we'll fine-tune its radius. Let's redraw the flow field. Now you can see the arrows within the sphere's influence area. All of them are being attracted, pulled towards it. So that problem is now fixed. If the effect isn't strong enough, you can always increase its size. Once all that's set up, we can duplicate the spline. Duplicate the entire thing, and assign it to the other team. Rotate it. Position it on the opposite side. Following the same pattern, click on Draw Debug. Perfect, that's also set up over here. Finally, let's increase the size of the flow field grid. Since we don't require that level of terrain detail, we can set it to 500. Once all these edits are complete, we can move on to spawning the monsters. Again, we'll open the level blueprint. Within the Begin Play event, use the Make Template Data node. And plug in our zombie actor. This time, we'll store its template data twice. Since we've got two teams, we'll name the first one Zombie Team 0. And the second will be Zombie Team 1. Next, we need to configure their fragments. We'll start by using a sequence node to set the mass fragment. We'll need 2 of these nodes. The other team will also need 2. First, let's configure the navigation fragment. Next, we have the trace settings here. Now enable check the navigation option. Next, we need to configure the flow field. For the trace, we'll need to set up both the mode and query parameters. For the mode, select by traits. Now let's configure the flow field settings. Drag and drop these two flow field actors into the corresponding slots. Team 0 will use the flow field assigned to Team 0. Similarly, Team 1 will use the flow field assigned to Team 1. Now let's edit the query settings. Here, click the Make button to create the query. Do the same for the other one. Click Make again. Let's edit Team 0's query first. For Team 0, set it to attack Team 1. Perfect. So we set the target tag to Team 1. And for Team 1, configure it to attack Team 0. Team null tag. They also share some commonalities. For instance, I want to filter out the dying tag in both cases. Perfect, that's all set. Let's move on to spawning enemies directly. Let's spawn the first enemy on the left side of the screen. Currently, it's at 23,000, so we can set the spawn cap to 20,000. However, at this other position, the value is also 23,000, which we'll also set to 20,000. We'll also utilize a sequence node here. We can configure it to spawn a wave every 3 seconds. For the spawn agents function, we want the enemies to appear in a square formation. Therefore, we need to locate and use the rectangular variant of this node. Again, we're using template data to spawn monsters. So, to find the right byTemplate function, we select the byTemplate rectangular version. There are two variants. One spawns instantly in the current frame, and the other, distribute the spawning workload across multiple frames. Since we're spawning a large number of monsters simultaneously, we should use the delayed version to maintain performance. We'll create 2 of these nodes. The first node will spawn zombies for Team 0, and the second node will spawn zombies for Team 1. Set the first spawn position to approximately 2,000, 21,000, and the second to about 20,000. Oh, right, that value should be entered into the Y coordinate. So this node is for Team 0, and the other one is for Team 1. For quantity, just put in -1. This way, we can spawn a whole square formation in one go. If you punch in a higher number, it'll only generate the exact number you specified. Now, let's set up the square formation in the shape data. Configure the length and width for X and Y. For the X-axis, let's go with around 10,000. Actually, 15,000 feels like the sweet spot for this size. For the Y-axis, 500 will do the trick. As for the spacing, since it's set to 100 by 100, setting it to 500 will generate about 5 to 6 rows in one go. Next, set the ground detection collision channel to world static. We can bump up the detection range a bit. Both sides can share a single shape data input. Then switch the orientation to custom mode. By default, it should probably be facing upward relative to the screen view. So that would be a rotation of roughly 90 degrees here. And the opposite side is also set to 90 degrees. If that's not right, we can tweak it later. For now, let's set it like this. The auto-activated checkbox is unchecked by default. That's correct, because we need to spawn them over multiple frames and then activate them all at once. So we'll distribute it across 30 frames. Then, once everything has been spawned, we bind a delegate event to activate all these delayed spawns, the agents, in one go. Same goes for the other side. This doesn't look quite right. Let me manually tweak the layout a bit. That should just about do it. Let's refresh and check the flow field preview. Let's turn it off first. The orientation seems fine. Actually, the orientation is off. Let me check. So this value here should be -90, and this one should be 90, right? Still not right. We should change this to custom rotation. Yeah, that's it. It has an initial 3-second delay before starting. For easier previewing, we'll just generate it once when the game starts on begin play. This makes debugging much quicker. All right, that works. So now we've spawned a single square formation. If we enable the FPS display, you can see that spawning thousands of monsters at once doesn't really affect our frame rate. That's because we've spread the computational load over many frames. Now let's test if they can actually fight each other. Place their spawn points close to each other. Say, set their coordinates to something like 3000, -3000. The battle works. This is how you can create a war sim. Alright, next let's see how to set up the FPS first-person shooter mode. First, we'll start with one of Unreal Engine's project templates. Open the Epic Games Launcher and go to your library. Find Unreal Engine version 5.6 or later and launch it. Click the Games tab. Select the first-person template. This variant is available in Unreal Engine 5.6 and later versions. Here, open the drop-down menu and select Arena Shooter. Save it to a location of your choice. Once the project is open, click the Content Browser. Navigate within the Content Browser and open the Arena Shooter map. Press the play button to test the level. The map already contains a playable character. You'll also find weapons scattered around the level that you can pick up. The character can shoot weapons and will die upon taking sufficient damage. Right-click on the map asset and select Asset Actions. Select Migrate to transfer the asset to your Mass Battle project directory. Once the migration is complete, you can close this project. We won't need this anymore. Now, let's head back into our Mass Battle project. As you can see, we already have these assets set up. Go ahead and click on the level menu, then open the Arena Shooter map. Let's run it. Okay, we're getting an error. But don't worry, this error is specifically about the NPC characters on the map. We won't be using any NPCs anyway. That's because our foot soldiers are going to be created using Mass Battle. So we can simply break that connection right here. Let's run it again. First off, let's check that our controllable character is working as intended, and also that our weapons are functioning properly. If everything looks good, we'll move on to simplifying this map by removing any unnecessary assets. This jump pad is quite useful, so we'll keep it. The nav mesh bounds volume, which handles navigation, we'll keep that as well. We'll also keep this weapon box. And the player start can stay as well. Everything else we don't need for now. Hold down Ctrl, Shift, and Alt keys to select and delete. Select and delete it again. Next, we can delete all these lighting actors. We should also delete any unused folders. The jump pad, pickup, and player start actors are all set. Now click on the window menu. Then select Env Light Mixer from the list. Now click through all the buttons at the top of the panel. Next, let's place a building or structure in this area. We can open the FPS map that comes with this plugin. We can copy this building here with Ctrl+C. Ctrl+V. Next, let's place a ground plane. We can simply use a cube for that. Scale it up and apply a less bright material to it. You can search for grid. Let's go with this one. Now, let's set up the navigation mesh. Center this nav mesh bounds volume and scale it up. Make sure it covers our entire playable area. Next up, let's place a player start actor. For instance, this will serve as a player's spawn point. Then, right in front of this spawn point, let's place a weapon crate. Perfect. We can pick up weapons as soon as we spawn. Next, let's drop a player start on the roof. This is also a spawn point. We can also toss down a couple of jump pads anywhere. For instance, we could put a jump pad right here. Then we can crank up its launch strength to 2000. That way, we'll get some serious air. All right, let's hit play and see how it works. We've spawned, we can grab weapons and start blasting. And over here, there's a jump pad we can use to launch ourselves. This entire structure is also traversable, walkable. The only thing missing is to spawn some zombies into the level. Now, let's begin spawning enemies. First, as usual, we'll open the level blueprint. Then, inside the Begin Play event node, we'll use our reliable method again. Make template from data assets. Again, assign our zombie data asset to create and save it as a template. Again, use the set mass fragment node to add navigation to it. Then, edit its target acquisition settings. Set the method to navigation. Check-tick the set member set flow field option. And here we have the trace set member setting. For the mode setting, we'll select target player directly. The query field can be left empty. Next, we need to configure the flow field parameter. Navigate to the plugins directory and find the core flow field canvas BP blueprint. Drag and drop a flow field actor into the scene, center it, and set its mode to nav mesh. Set an arbitrary point as the pathfinding destination to test if it's working correctly. Once you've confirmed it's working properly, plug that flow field actor reference into this parameter slot. And that's it. The basic configuration is now complete. Now we're ready to start spawning enemies. For example, we could set it to spawn a new enemy every 0.2 seconds. Then we use the spawn agents. We hope to center around this point on the map. That is, monsters spawn in a circular pattern around this building. So we need a circular. Then by template it is. Each time you apply a template using our template data, team using team 1. Origin refers to the map's datum point without any issue. Edit the shape data, this is a ring shape. For the outer ring, 4000 for the inner ring. Let's set this to 4000 as well. Next, we can configure a random offset here. This will make their spawn positions appear more randomized. Now we want them to spawn on the ground. So we'll specify the ground object channel here. When searching for the ground, we can use a broader detection range. Facing player 0 is correct. Auto-activated, these settings are all set. And that's basically it, no other issues. Let's spawn some enemies and test it out. The character is clipping through the geometry here, so we need to enable collision detection. Now let's dive into fine-tuning and optimization. Specifically, we'll optimize the pathfinding system and agent environment interactions. First, open the agent data asset. In the collider settings, select multiple cells. This provides higher collision precision. Then navigate to the Move XY section. We can lower the deceleration value and reduce the ground friction. This makes the turning more natural, creating a sense of momentum. Next, let's adjust the setting. This makes the forward movement speed greater than the reverse speed. Now, let's enable the Do Scene Trace checkbox. The detection channel used here isn't the object channel. This is a trace channel. To understand trace channels, let's open any model asset. Let's open a model. Inside, you'll see the Collision Presets section. This is where you configure how the model interacts with different trace channels. We can use this camera channel. Alternatively, you can also create a custom channel. We'll set the detection to target this camera. Next, for ground detection, we'll also use a raycast. The detection will also use this camera channel. Next, for obstacle avoidance, we can set the perception range wider, for example to 250. The agent's avoidance reaction time can be set lower. This will make the agents push and shove each other more intensely. Next, the reaction time range for pathfinding. It refers to the arrows displayed in the ground's flow field visualization. For instance, when transitioning from this value to that value, the system's reaction time, We can set it to have a randomized reaction time. This will result in more natural-looking behavior. All these settings look good as they are. Now let's examine the z-axis parameters. For the z-axis, we can reduce the maximum ascent speed slightly. Let's set it to 2000, for example. That covers the maximum ascent and descent speeds. Both look good. Next, let's adjust the yaw setting. Right now, the orient to path behavior feels a bit rigid. We can switch it over to align to movement here. Next, let's crank up its turn rate to 2000. Let's also bump the acceleration up to 2000. We can set the collision iterations here to 3. Alright, that should take care of the major issues. Let's tweak this flow field a bit more. As it stands, this flow field looks a bit too grid-like and rigid. See here, so the agents make a sharp 90-degree turn. That's a perfect right angle. As you can see, it's taking this 90-degree zigzag path. It doesn't look very natural. That's why I'm going with this flow field. Next, I'll crank this value up a bit. This way, if a closer, better path is available nearby, that offers a more direct, shorter route, it will take the diagonal shortcut. Now you can see it's starting to cut corners. Instead of moving in strict grid-like straight lines, the result is a much more natural-looking movement. And then there are also these spots. Imagine if an agent follows this arrow path and might get stuck right here. For instance, if both of these arrows are pointing upwards, the agent could get jammed up right at this point. And this area is just a flat surface, with no curvature to it. The agent will be stuck there for ages. For spots like this, we need to tweak the navigation mesh. For example, we could add a modifier. Next, we search for the nav modifier volume. This is a built-in feature of Unreal Engine. Place it in the area we want to optimize. Then set its mode to obstacle. This will mark it as a high-cost area for pathfinding. We can also adjust its shape. Look for the brush settings. It's currently set to box. We can change it to a cylinder. This will change its shape to a cylinder. For the cylinder shape, we can fine-tune its size. Then we can assign one, e.g. a navigation modifier, to each pillar. Now let's recalculate the flow field and take a look. A good result we can see is in this area highlighted in red. It's not an absolute barrier, but rather it's an area agents should try to avoid if possible. So if an agent finds itself inside this area, it will prioritize exiting first, before resuming its normal pathfinding routine. This way, it's much less likely to get stuck on the pillar, because it now knows to steer clear of this pillar. Let's run it and see what happens. Let's see how the agent handles these obstacles. It smoothly navigates around them. It doesn't try to force its way through or get stuck. Here, you can see the agents are all trying to cut corners. And then they fall off. We can turn this edge into a high-cost region. This will discourage the agents from hugging the edge. We'll add a modifier again. And we'll stick with the obstacle mode. Enlarge it slightly. Now let's trace out the edges of the staircase. Next, let's recalculate the flow field. Now you can see the agents maintain a safer distance from the edge. If an agent gets too close to the edge, it will try to pathfind away from it. There's still a minor issue in this area. Let's take a closer look. Adjusting this parameter doesn't seem to have any effect. In that case, let's try adjusting its dimensions. That's looking much better now. Check if there are any more issues of this kind of wrong way driving. Test again. Finding the right path requires everyone to conduct multiple rounds of debugging. It's hard to say that relying on a single algorithm can automatically generate everything everywhere. the perfect Pathfinder tailored just for you. So it's still important to keep trying more. The more time you spend, the finer the adjustments become. The better the effect of agent movement will be. Our plugin is one that prioritizes performance. We cannot allow every agent to have exceptionally complex computations. Top-tier intelligence. So if we want both speed and natural-looking movement, the only way is to use third-party data to guide their movement. So our pathfinding flow field is essentially a tool that guides their pathfinding. That's why it needs to be set up properly. Looks good, no issues here. Performance seems solid too. Let's test it by spawning a bunch of agents. Let's see if it runs smoothly. Looks good, no problems. Next, we can start fighting these zombies. First, we need to make our bullets able to hit the zombies. So we need to find this bullet's blueprint. Then we'll edit it. We can look on the left side, find the event graph, then add a begin play node. This executes when the game first starts running. First, use getActorLocation to save its initial position. This is the location from the previous frame. Next, add a tick event to it. First, we'll perform a spherical sweep. Sweep from the previous frame's location to its current position. This way, we can detect any agent it passes through along the path. Use the sphere sweep for agent node. Set the start point to the pre-location from the previous frame. Set the endpoint to the current getActorLocation. A sweep radius of 2 should be sufficient. All right, let's see. Sorting isn't required here. These likely don't need a query either. Let's just set them up. This is to prevent us from accidentally damaging our own team. In the query section for the all filter, we'll set it to only damage team 1. And then exclude any agents that are already dead. Here we'll use a process overlap node. This is a feature added in the latest version. It likely wasn't available in earlier versions. This setup will output a list of agents that have just begun overlapping. For actors whose begin overlap event has ended, we apply damage. Here, use apply point damage and debuff. Plug the begin overlap event reference into this slot. The hit from location should be set to the bullet's position from the previous frame. For the damage parameter, input the bullet's position from the previous frame. Populate the debuff parameter as well. Here we add a knockback effect. Uncheck this option. Since we can't get the damage results, the variable will be empty. If it is empty, then we proceed as follows. Since we haven't dealt any damage to any agent, we'll record the position for this frame. So when we use it next frame, it will have become the current frame's position. If we do deal damage, then we destroy the actor. The bullet disappears. All right, let's run it now and see the results. Pick up the gun and fire. The only thing is, the knockback direction feels a bit off. Let's take another look and change it to hit from instigator. Then we need to fill in this instigator parameter. This way, no matter how we attack it, it will always move away from our player character. Next, we need to make our player vulnerable to attacks from the agents. Therefore, it also requires a mass battle agent component. Assign the player data asset we created earlier to it. Set its team affiliation to 0. Next, change the query mode from entity to component to entity. This effectively binds the player's agent to the player's character, ensuring they move in sync. For health points, let's give it a higher value. Then we'll add an interface to it. Agent interface. Now, looking at this blueprint, we have the damage handling functionality. This is the on-hit event, so we'll replace it with the plugin's version, Mass Battle Agent On Hit Implement. When the agent takes damage, we'll use this plugin node to override the original one. Next up, the damage dealt event is basically the same as any damage. We need to disconnect this damage output pin. Now, let's look at the death event. For the death functionality, we'll use the plugin's death event node to replace it. Death. Disconnect the original connection first. Next, we need to make the zombies chase the player. All right, there's one more step to go. Let's go back and find that character we were just using. At begin play, use a getActorOfClass node. Target it to get the flow field volume that's in the level. With that reference, we'll call the setGoal function on our zombie entity. We'll set the goal to be the zombie's own current location. And now, the zombies will pathfind toward and chase the player. Finally, let's turn up the flow field update rate. All right, go ahead and disable the player's draw debug. It's coming at us and hits us. We're taking damage. But we didn't die. So here's the thing. The health value shown here doesn't match our actual health. This should be 500 HP, but we only have 100. Wait, if 100 here represents 10,000 HP, then multiplying by 5 should give us 500 HP. That should fix the mismatch. Let's check it again. I noticed earlier that even though our health bar looked empty, the enemy was still attacking us, meaning we weren't actually dead. This should fire off without a hitch. Then we respawn and bite the dust once more. Let's give it a whack and see. Seems to be working like a charm. Hold on, there's one more thing I completely spaced on earlier. When we deal damage, we should plug in the instigator here. In this spot, we can grab a reference to the player character. Next, we'll use the getComponentOfClass node. This is how we'll locate the Mass Battle Agent component. And here we'll get the handle from it. Drag it in. Thus, the player can gain the points for defeating it, among other things.